Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight I'm doing another special video, and this video is titled Winter Storm Alert. And this winter storm alert is looking at the midday models for 17 January 2022, and confidence is definitely increasing. It has increased over the past 24 hours that the Mid-Atlantic is the main focus being eastern North Carolina and southeastern Virginia, is definitely looking at the potential for a fairly significant winter storm coming up. And so let's get right into the discussion. All right, so things start, I'm starting things off around Thursday, the 20th of January, this Thursday. And let me go ahead and get my tool out again here to point some certain things out. All right, so let's take a look at the overall synoptic setup for Thursday, the 20th of January, 2022. This is the time period where things really start, getting the stage set for a potential winter storm. There's a 1,043 millibar high pressure system located over western Minnesota on Thursday morning, the 20th of January. The clockwise flow around this high pressure system is going to usher in very cold Arctic air. All right, so we're going to have very strong northerly winds into the Midwest, parts of Illinois, and those northerly winds will work their way behind the Arctic front. Now, the Arctic front will be positioned generally just to the northwest of Hampton Road cities on Thursday morning, the 20th of January. So you're looking at some rain showers, just some regular liquid precipitation preceding the Arctic frontal passage. As this high pressure sits to the northwest and ushers in much colder air on these northerly winds, the precip changes over to snow in parts of West Virginia, eastern Kentucky, eastern Tennessee, into parts of northern Virginia, on up the I-95 corridor, up through Philly, up through New York City, and even some snow showers there in the Boston area. All right, so we have rain changing to snow on Thursday morning. All right, and then here on the right shows the GFS 2-meter temperature anomaly in degrees Celsius. And I just really want you to look at the reservoir of cold air behind this strong Arctic front. So this purple shading in the upper Midwest, for example, that indicates temperatures, below normal temperatures on the order of 16 degrees Celsius below normal in this area, the lighter purple shading. But look at the other purple coloring, and you can see a distinct line where that Arctic front is situated by Thursday morning. You see the red colors and orange colors out ahead of the front, indicating the milder air. But immediately right behind it, the temperatures are going to crash. All right, so now we're going to move forward a little bit later on Thursday, the 20th of January. So this first slide I'm showing you is for Thursday morning. This next slide I'm showing you is for Thursday afternoon. And by this point in time, a 1040 millibar high is situated in the vicinity of Minneapolis-St. Paul, Minnesota. And there are some strong northerly winds blowing in to the area, across the Mid-Atlantic specifically. And notice how the rain changes over to snow. All right, and now look at how these purple colors have now advanced all the way to the Virginia coast, into Maryland, D.C., all the way to the New Jersey coast. So the colder air is settling itself in. The rain is changing over to snow across southeastern Virginia. So see how the advancement of the Arctic air is the purple coloring here? This is morning on Thursday. This is early afternoon on Thursday. Now on Friday, the 21st of January, I'm going to show you 3 different models in tonight's video. This is the GFS model. I'll kick it off with GFS first. And then, by the way, these are all midday models. Okay, these are the 12Z model runs for today, 17 January 2022, and they are projections. All right, so we'll start off with the GFS model. Now, this time period, I moved it ahead now to Friday, the 21st of January, at about 1 p.m. local time, Eastern time. All right, and you'll notice this blue shading across parts of eastern North Carolina, just off the southeast Virginia coast. There's a very strong 1035 millibar high situated there over eastern Canada, funneling in much colder air and lower thickness values along the eastern seaboard. And so what's going on Friday afternoon, there's a wave of low pressure that's forming along this Arctic frontal boundary just offshore. And then by Friday evening, the 21st, you notice how this light blue coloring is on the very northwestern side of the storm, which is situated over the western Atlantic. And so you get a wave of low pressure to form along the front according to the GFS model, and then that wave of low pressure heads out to sea and just scraping parts of North Carolina with some snow. Okay. Now, let's continue on our discussion with the GFS model, and notice now we're moving ahead to, this would be overnight Saturday night on the left. And so there's a new area of low pressure. There's a new storm system that has formed off the southeast coast with ice to the northwest of it, extending from northern Alabama, northern Georgia on into parts of South Carolina. There's snow on the northwest side of this towards the western parts of North Carolina. That is on Saturday night, overnight, while we're all asleep. And then this graphic on the right shows Sunday morning, the 23rd of January. And now notice how that wintry precip has advanced northeastward towards eastern North Carolina into southeastern Virginia. The area of low pressure is intensifying, and it's moved a little bit off to the northeast by this point. So the GFS model is showing what I seem to think two different pieces of energy. Okay, for sure we know, and there's pretty high confidence that we're going to see an Arctic front coming through the area, through the mid-Atlantic on Thursday, the 20th of January. Very high confidence in that occurring, and very high confidence in the rain changing over to snow. All right. Where things differ is Friday and then Sunday. The GFS model has two distinct pieces of energy. One Friday that moves offshore, and the other coming up and developing off the southeast coast Sunday. So GFS is looking at two distinct pieces of energy, two distinct pieces of two storm systems in general. Okay. Now, let's look at the Canadian model. All right. So the Canadian model on the left here, I'm showing a graphic. This is for Thursday morning, the 20th of January. And again, the Arctic front is approaching the mid-Atlantic. There's some liquid precipitation, some rain showers into Virginia, on down through eastern Tennessee, into the deep south, Mississippi, Alabama, Louisiana. And then that changes over to snow from West Virginia down to eastern Kentucky and central Kentucky and parts of Tennessee, western Tennessee. And then by the, this is overnight on Thursday night, 1,041 millibar high over Iowa, pumping in much colder Arctic air behind the Arctic front, a wave of low pressure well out to sea. But on that very back side, as the front moves through the area across southeast Virginia specifically, you see a conversion from rain to snow overnight. And then the Canadian model on Friday. Let's take a look at this. All right. So very similar to GFS, where we get a stalled frontal boundary right offshore, but a little bit different now. I'm going to show you the progression of the Canadian model. So this is Friday afternoon at about 1 p.m. local time, 1 p.m. Eastern time. We have plenty of cold air in place. Look how low these thickness values are. All right. So very cold Arctic air in place. We have a wave of low pressure developing along the stalled boundary, and there is snow breaking out from northeastern North Carolina to southeast Virginia, in parts of western Virginia and eastern Tennessee, and then there's ice over parts of North Carolina, and then there's some rain down along the South Carolina coast back towards Georgia. Now look what happens with this wave of low pressure. Now we're moving ahead to Friday evening, and now we're looking at all snow, and the snow starting to increase in intensity as this wave of low pressure really develops. And so we're looking at fairly decent snow from North Carolina into southeastern Virginia. And then we have ice again over parts of coastal North Carolina down to South Carolina. And then we have rain just offshore. Okay, so let's continue moving it through. This is Saturday, 22nd of January on the Canadian model. Look how this low pressure system is really getting its act together. And then you have all the cold air in place on the northwest side of this low pressure, the storm track, and you're getting fairly significant snow across southeastern Virginia and parts of northeastern North Carolina. Now this would be overnight Friday night according to the Canadian model. Graphic on the right here shows Saturday morning with the storm slowly pushing itself out to sea further offshore, but we still have a lingering shield of snow on its backside. The snow should be tapering off by noon local time according to the Canadian model. But when all is said and done, and I'll show you the snowfall maps in a moment, the Canadian model is showing quite a bit of snow. So overall, in summary, the Canadian model shows low pressure offshore with continuous snow falling over southeastern Virginia through early Saturday afternoon, most likely to be wrapped up around noon at the latest, is the way it looks right now in the timing. But think about this. The snow is starting on Friday afternoon and could progress to, well, about 12 to 18 hours in total time, continuous snow falling. So that would add up to some pretty good accumulation amounts. And, by the way, the Canadian model remains the most consistent. I've been watching this over the last 3 days, and the Canadian model is just sticking to its similar track, its similar intensity. We do see some differences here. So this was the 12Z 16 January model from the Canadian, showing low pressure just right off the mid-Atlantic coast with, again, snows in similar areas. And this was 00Z 17 January, similar situation. Low pressure was a little bit further south on the 00Z model. Okay. And then this would be 12Z. This was today's model run on today on the 17th of January, the midday run. And look where the snow is, and look where the low pressure is. So overall, the Canadian model has been the most consistent model. It's been more consistent than the European, because if you remember my video yesterday, the European temporarily really didn't show the storm anymore, right? And then it came back to showing it again. But Canadian, it's been pretty consistent. I take note of that. That's a trend. Now let's look at the European model forecast for the upcoming storm this weekend. So up here in the upper left, we have the valid time for Thursday, the 20th of January, and this would be at about 7 a.m. local time, Eastern time. We see the Arctic front approaching. Okay, Arctic front's approaching southeast Virginia and going through the mid-Atlantic. We see rain showers out ahead of the Arctic frontal boundary with the milder temperatures and the higher thickness values. And then by Friday, or actually this would be Thursday night, we have the Arctic front pushing through the area, and we still have some lingering moisture stretching from southeast Virginia on down towards the Florida Panhandle, towards Pensacola, by Thursday evening, the 20th of January. And then, bottom left here, now things get interesting. This is this is Friday evening. This is about 7 p.m. Eastern time on Friday evening, and that stalled Arctic boundary, you get some really strong temperature contrast from both sides of that boundary. A warmer air over the Gulf Stream of the West Atlantic, much colder Arctic air to the northwest, a very deep trough, and you get a wave of low pressure to develop along this front, very textbook, and you get a shield of snow spreading into southeastern Virginia Friday night, and then down through North Carolina. And then over here in the bottom right, I'm showing the graphic. This is the forecast in the European model for, this would be overnight Friday night, where we see a pocket of very heavy snow advancing from northeastern North Carolina into southeastern Virginia. The area of low pressure is situated off the coast at this point. So the European model, the last two cycles, the model cycles, has shown this similar pattern. Now, we not only need to look at the surface, but we also have to look above the surface at about 18,000 feet or at 500 millibars. So what I'm doing is a model comparison at 500 millibars. Where is that shortwave trough? Where is it in relation to southeastern Virginia, for example? Okay. So this upper left-hand graphic is the GFS 500 millibar geopotential heights, and the orange coloring on these charts indicates areas of rising air motion, what's known as positive vorticity. Okay, so this GFS model is showing, this is Friday evening at 7 p.m. Eastern Time, showing a significant shortwave trough developing, extending from New York State right on down through western Virginia. So you're going to get a lot of cyclonic turning with this very sharp it's a very sharply amplified shortwave, so you get a lot of cyclonic turning here. This is where you're going to typically, the 500 millibar shortwave is going to support your surface storm development. So the position of the shortwave is located pretty much through Virginia, the axis of the trough. Now let's look at the Canadian model here on the right. Notice the trough is orientated a little bit further back to the west through western PA, down through West Virginia and western part of the state of Virginia. Okay? And then finally, look at the European model. The European model showing a significant area of vorticity, this orange coloring. Here's a scale, by the way, the vorticity. And so the shortwave trough is positioned from Pennsylvania right on down through southeastern Virginia on the European model by Saturday early afternoon. So it's very important to pay attention to these upper level features which help to guide the storm along. It determines precipitation types when you have these winter storm setups. And it also really helps you to pinpoint that rain-snow line, okay, by looking at this. Now, the stronger these vorticity values in the positive side of things, the greater the lifting in the atmosphere, okay? So if we look at not only the surface track, but also some of the upper level features, okay? Let's start off here on the left, and let's take a look at the 850 millibar level in the optimum region for heaviest snow. So 850 millibars is located about 5,000 feet above the ground. And this is your low, the upper level low at the 850 millibar level at basically 5,000 feet above the ground. And right in this particular area, you have a lot of moisture advection. So there's a lot of moist air being lifted. And just to the northwest of this 850 millibar low, this is usually the sweet spot for the heaviest snow to occur. So we get optimum lift and 850 millibar temps on the order of -2 to -6 Celsius for heavy snow right in this location. So you notice these dashed lines, these are your what's known as isotherms, lines of equal temperature. And so when you get really tight packing of these isotherms, that's a large temperature change over a short distance. And generally on the cold side of the upper low, that's where you're going to get the snow. If you look at the 500 millibar trough in the optimum snowfall region, if this is your upper level low, you typically have your 500 millibar trough axis, your shortwave trough axis to the west of that, and you typically get your optimal snowfall region just to the northwest of the 500 millibar low. So are you getting the pattern down here? You want to be located to the northwest of these low pressure systems, whether it's at 850 millibars at 500 or 5,000 feet, or at 500 millibars, 18,000 feet. You want this upper level low to be to your southeast. If you want snow, this is what you want. You want the track. So you can't just pay attention to just the surface low track. Although that's important, you have to look at the 850 millibar level as well as the 500 millibar level. Okay? And usually, I want to mention with this too, with this dashed line, this is your trough axis. Typically, you get the greatest values of vorticity, positive vorticity, right ahead of the shortwave trough axis. This is your area of positive vorticity advection, or what's known as PVA. Okay? And so the atmosphere is a three-dimensional machine, from the surface all the way up to the jet stream level. And I'm not even showing you the jet stream level. I'll definitely do that in the next video probably. But with the jet stream level, you're looking at these jet maximum that are moving through the core of the jet stream. And there's some specific quadrants that favor the removal of mass aloft. And usually that's in the left front and the right rear quadrant of the jet max. And, that's also favorable. So, again, the atmosphere, the way storms work, it's three-dimensional. We can't just pay attention to what's on the surface. We have to go higher and higher up in the atmosphere, from the surface all the way up to the 300 millibar level, up to the jet stream, and see what's going on and see how these areas are overlaid upon each other. Now, in the upper right-hand corner, I wanted to also show you why the surface storm track is important, because generally in the northern hemisphere, the winds are going to blow counterclockwise around low-pressure systems. And so to the east, or to the right of the storm track, you're going to get much milder air because winds are generally from a southerly quadrant or direction. And on the backside of this low-pressure track, you get the much colder air. that comes around on northerly and northwesterly winds. So you get the snow to the left of the storm track, and you get the milder temperatures and rain to the right of the storm track. So again, that's why it's so important. You look at all these features, the surface low, the 850 millibar low, and then the 500 millibar trough, and you put it all together, also with the 300 millibar level where the jet stream is, to determine if you got an extra bit of wind energy in these jet maxes, and it all comes together to create storms. I also tonight in the video wanted to compare different storms in the past, winter storms in the past that were pretty significant for Hampton Road cities particularly, and for the Mid-Atlantic, all the way to the Virginia coast. The first graphic here, courtesy of NOAA on the archives, shows a very intense area of low pressure. Now this first map here on the left was December 2010. Actually, this chart is from December 26th of 2010. And this was one heck of a storm for Hampton Road cities. 14 inches of snow fell. And what happened is, see this blue dashed line right here? This is your freezing line. This is your freezing line here. So anything to the left of that line is below freezing. Cold enough for snow. Anything to the right of that line out over the ocean is warmer than 32 degrees Fahrenheit, and that's rain. But you get, this particular storm produced 14 inches of snow, and look where the area of low pressure is. It's situated just to the southeast of the area. And that's the track you want if you want snow in Hampton Roads, all the way to the Virginia coast. You have to keep this low pressure center offshore. You have to keep it to the southeast. Now let's compare this map in the middle. Now this is from January 4th of 2018. This was one heck of a storm. All right. We got 10 inches of snow in Hampton Roads, and this thing bombed out. This thing just really bottomed out the barometric pressure. And look at the position of it again, though. I want you to pay attention to the position. See how it's offshore? It's not right along the coast, and it's not just to the, like, over Outer Banks even at this point. This is well offshore. Not too far offshore to where you don't get any winter precip. It's still close enough, but you remain in the cold air. There's that blue dashed line again. See this? This is your freezing line. It goes offshore of the Virginia coast, actually all the way offshore of New Jersey on into southeastern New England too. And so there was a massive snowstorm from southeastern Virginia all the way up into New Jersey, into parts of Long Island, up through southeastern Massachusetts. This was a doozy for a lot of people in a very populated area of the East Coast. Now let's take a look at the forecast for this Saturday. All right. So if we compare the December 2010 storm to the January 2018 storm to this Saturday's forecast, look where the low pressure is in each case. Offshore, offshore, and offshore. And that's what I want to get at. This is why the storm track is so critically important if you want wintry precip all the way along the Virginia coast in southeastern Virginia. Hampton Road cities, this is what you want. Okay? And so this is why we talk so much about the storm track and why it's so very important. Now, is this storm going to be like the December 2010 storm or the January 2018 storm? I'm not saying that. It's too early right now. The details are still being worked out. Cannot make that call. And we'll just have to keep an eye on it. I like to compare past storms, and I like to show these past storm tracks when we got big winter storms. Now, let's take a look at the snowfall maps. GFS, Canadian, and European. We're going to start with the GFS here on the left. And GFS, whoa. I don't know what GFS must have drank some pretty good Kool-Aid. When you got 14 inches of snow situated over south central Georgia, I tend not to believe it. I mean, it is possible. We saw it with the March 1993 superstorm where parts of Alabama got over a foot of snow, but that was a very exceptional case. So this was the midday GFS run showing the heaviest snow generally from northeastern or southern, south central North Carolina down through South Carolina down to Georgia. This is a Canadian model. Now look where the snow is, the heaviest snow. Now these are the legends in inches on the right. So right now, look at that figure there. It's kind of hard with the outline of the coast there. But Canadian model is showing right around a foot of snow over southeastern Virginia, including Hampton Road cities. and then that stripe of heavy, heavy snow goes all the way up towards Boston. Okay. Now, what about the European model, midday run, 12Z, 17 January? Pretty good snow. Pretty good snow. 8 inches in the Hampton Road cities, 12 to 14 inches along Interstate 64 between Richmond and Charlottesville. So really good. And then that heavier snow, 12 inches plus, works its way all the way up towards southern New Jersey, Long Island. Look at New York City, 11 inches according to the European model. And then works its way on up 10 inches in Connecticut around Hartford. And so this would be a really, really impactful storm for a lot of people if the European is correct. So now let me delve into my final thoughts for tonight's video. First of all, I have to start off with bullet number 1. There is lots of uncertainty that remains among the various weather models for the Thursday to Sunday time period. And these models are going to constantly change between now and then. I do like the consistency of the Canadian and the European models. You look at the trends. Have they fluctuated much over the last 24 hours? The Canadian and the European models, no. Now, the GFS model has been the most inconsistent model for this storm. And I just gave the GFS some great props yesterday on my video, how it handled this past storm so very well. But right now, the GFS is struggling. You know what? It's struggling because it's trying to figure out what to do with all these pieces of upper level energy. It's struggling because it's looking at dividing up. Instead of one big storm like Canadian and European show, the GFS model is showing 2 distinct pieces of energy, 2 distinct storms. It's showing the initial storm, here's GFS, it's showing the initial storm there Thursday into Friday, and then it has a break Saturday, the GFS does, and then has a much more intense storm on Sunday, right? The Canadian model says, okay, I see a storm on Thursday. I see that storm, a little bit of a break Friday morning on the Canadian, and then it picks back up Friday afternoon, all night Friday night, and into Saturday morning. That's a Canadian. And then the European is also showing, similar to the Canadian, where you get the stalled Arctic boundary and you get a little bit of change from rain to snow as the Arctic front moves through southeastern Virginia and the mid-Atlantic on Thursday, and then break Friday morning, and then things really pick up on Friday afternoon all the way overnight into Saturday. All right, so low confidence right now, not 100% firm. But the confidence is increasing for a significant snowstorm across southeast Virginia, including Hampton Road cities Friday and Saturday. Friday the 21st of January, Saturday the 22nd of January. But again, it's way too early for specific snowfall amounts. I'm not going to sit here and post these on social media, okay? Some people post these fantasy snow maps. We're too far out. We're too far out in time. I don't trust any of these maps yet. All right? So, just wanted to give you an idea of what type of storm we could be looking at with these accumulating maps. But again, that's going to change. It's going to change based on the storm track. And remember, the way these features set up their track. 500 millibar trough, and the low pressure upper low there at 850 millibars, and the surface track on the far right. That's what's going to determine who gets what. Now, the Canadian model, I am very impressed. It has been the most consistent with the storm signal. Now, the Canadian model actually had an upgrade back in December, and it's supposed to have better resolution. Canadian model used to be a third place finisher. Used to be the European model was the best model, then the GFS, then Canadian. The Canadian model has been impressive as far as consistency with the storm signal and the track overall. The European model shows a stronger storm system with higher snowfall amounts, while the GFS has been highly inconsistent, as I mentioned. I don't really trust the GFS model right now because of the inconsistencies. So, for example, last night in the GFS 00Z run, it showed pretty much it went in alignment with the European as well as the Canadian. But now the 06Z, the 12Z, and now just recently the 18Z a couple hours ago, GFS, has shown hardly, like 2 pieces of energy. The event on Saturday is just non-existent. And, I just don't trust the GFS. I think it's still trying to figure things out here. Now the storm track is very important, obviously, as to what type of precip you see. Whether it's a cold rain, whether it's a mix of rain and snow, or whether it's just solid snow. And the duration of those precip types. That is so critical. The longer we see snow, the greater the snowfall accumulation amounts, right? If that track of the 500 millibar low, that low pressure at 18,000 feet above the surface, and that surface low, if they remain offshore to the east-southeast of Hampton Roads is going to get hit hard with this one, with very significant accumulation. And what do I mean by significant accumulation? That is greater than 6 inches of snow. If those two features track offshore and remain offshore. So there's a high confidence we will see a rain. All the models are showing this first bullet here. High confidence we will see rain change to snow by Thursday evening, the 20th of January for Hampton Road cities, as Arctic air moves into the area. That is pretty solid. Very consistent. There's not much disagreement. It doesn't matter if we're looking at GFS, European, or Canadian. They're all saying the same thing. So therefore, our confidence is higher for that to occur. And we could see 1 to 2 inches of snowfall possible late Thursday night into Friday morning as that rain changes over to snow as the Arctic front moves through. Now, this is mainly for Hampton Road cities. A wave of low pressure is going to form along that stalled frontal boundary, separating very cold Arctic air to the northwest over land and milder air over the warmer Gulf Stream current. So you get a wave of low pressure to develop along the baroclinic zone, separating the very contrasting air masses, cold and warm, and that's going to push precipitation northeastward towards southeastern Virginia by this Friday afternoon. So we might get a little bit of a break on Friday morning as the Arctic front, that precipitation kind of winds down and pushes off the coast a little bit. We'll get a little bit of a break Friday morning, but then by Friday afternoon, you'll have some overrunning precip at the upper levels, overrunning that cold Arctic air at the surface, and snow will start falling again. So we could potentially be looking, the way we're looking at it right now is for a period of continuous snow from Friday afternoon through Saturday morning. Now that's going to make travel very hazardous across southeastern Virginia, especially Hampton Road cities. We just don't have the snow removal equipment in southeastern Virginia. So, many of you who watch this and have lived through past winter storms here, you know what I'm talking about. There's just, outside of the major interstates, the Virginia Department of Transportation, they just don't have enough plows and equipment to clear side roads and other non-essential main roads. So it's going to get, if this occurs, now again, I mentioned possible, or I mentioned the word potential, because this isn't etched in stone yet. This is just the way I see it right now based on the models today on 17 January. We get a period of continuous snow. It is possible, and it could be occasionally moderate to heavy overnight Friday night if this Canadian and European track verify. The winds are going to increase too, and they're going to increase from the north, specifically on Saturday, as the low pressure system is just right offshore. And so you're going to get very strong northerly winds, lower wind chills. You'll have snow falling probably through about midday. Now the European model extends the precipitation into the early afternoon Saturday, but regardless, it's going to be very windy. And one other thing I want to mention about these type of storm systems, they're very dynamic. You get these very smaller, finer scale processes that are very important during these types of events, where you get this mesoscale banding effect, where the global models just aren't going to pick this up. You got to go into the more mesoscale, the smaller high resolution models are going to pick up the smaller scale processes. And with that, with these smaller scale processes, you can get a convective nature to the snow. Because, believe it or not, the atmosphere is unstable. We think about the atmosphere being unstable in the summertime when it's hot and humid and the air rises, you get these thunderstorms that develop. Well, you can also get this instability during winter storm events. And what happens is, with these convective bands that set up on the backside of your storm system where you get the greatest lifting, and you get the area which is associated with what's known as a trowel, a T-R-O-W-A-L. Look that term up. T-R-O-W-A-L. Trowel, a trough of warm air aloft. And that is a lot of, basically what trowel is when you lift a lot of warmth and milder and moist air in the vertical, and it wraps around a very mature cyclone. You can get heavier snowfall rates at times in these convectively unstable bands on an order of 1 to 2 inches per hour over a very localized area. This doesn't occur over a large stretch. I mean, you can have, accumulations because of this, total storm accumulations up to a foot, and then you drive maybe 15 miles to the northwest and you have half that amount. You might have a foot in one location where these mesoscale bands, this convective instability occurs, and then 15 miles to the northwest, maybe you only have 6 inches. All right. You can also get a phenomenon that's known as thunder snow. And thunder snow, you probably have seen Jim Cantori really going off about thunder snow when he's been doing reports in some pretty strong low pressure system storms. And you can get thunder snow. And I grew up in the Midwest, and I've seen some of the heaviest snowstorms have lightning and thunder with them. It's just really crazy to think that could even occur. But you get the heaviest snow amounts with those bands. So we'll have to watch that. Now, 3 possibilities still exist, though. All right. Primarily, this event could be all snow with an occasional mixture of rain and snow. That's the first scenario I believe could happen. The next scenario or possibility is a mix of rain and snow, cutting down on the potential for accumulations. Or we can go snow to rain as a warm nose moves in off the western Atlantic Ocean, similar to this past storm. Now, right now, based on the models, what I'm thinking, the 12Z 17 January models, we're thinking it's going to be primarily a snow event in southeastern Virginia. Occasional mixing is possible closer to the coast. Definitely Virginia Beach, closer to the coast. Anywhere along the water, you could have a little bit of occasional mixing. But we still think it's going to be primarily a snow event in Hampton Road cities on Saturday. And snow could be moderate to heavy at times. Again, that has to do with this term right here, this first bullet, about the convective instability. And temperatures are going to remain close to 32 degrees. That's the other point I wanted to get out there. And what does that mean? That means the conditions are very ideal to get the greatest snow to liquid ratios. So you are maximizing and getting the most moisture in the form of snow out of the atmosphere when you're near 32 degrees. Because 32 degree air can hold, first of all, it's critical because it's near the freezing point, right, to get the snow to begin with. But in addition, 32 degrees, the air has a greater capacity to hold moisture. All right, and we're using the 10 to 1 ratio there. 10 inches of snow equal to 1 inch of liquid precipitation. All right, so that wraps things up tonight in this special video. This was a video update, winter storm alert for this. Really, we'll start seeing the first flakes with the Arctic front on Thursday, the 20th of January. And we could see a light accumulation with that. Now, keep in mind the ground will be wet because initially we'll have rain and mild temps. But then Friday afternoon through early Saturday afternoon, I'd say, that's the real time to watch. Now, again, differences in models. That doesn't give us the greatest confidence that this thing's going to happen. But with the European and Canadians pretty much indicating what they are, and if you take a look at the latest National Weather Service Wakefield Office forecast discussion, as well as the hazards forecast by the NOAA, put out by NOAA, the hazards for the next 3 to 7 days, all signs are pointing favorably for a significant winter storm across southeastern Virginia down through the mid-Atlantic. And then, potential, it could go up the coast, further up towards New England as well, and produce some really nice storm if you want snow up in New England. So again, there's a lot to talk about. Just wanted to make another video today to kind of give an update on what the models are looking like today on the 17th of January. And we'll see how things turn out here as we continue to watch each model cycle. All right, that wraps things up. We're spot on weather. Hope you enjoyed the video, and hopefully you learn stuff during these videos too. I try to teach a little bit. I just have that teaching in me to help break it down and make it easier for you to understand at home. We're spot on weather. We believe in accuracy through precision and the most detailed analyses possible. Take care, everybody. Stay warm. It's kind of breezy out there tonight. Stay warm and take care, and God bless. Until next time.